Ciao friends! With the introduction of composite models, Taxa has been enriched with new functionalities that were needed in order to make composite models over analysis services to work. You now have the option of creating calculated columns and calculated tables inside a query, and they also added a lot of new functions that we are still studying, and they will be a topic for a different video. In this video, I want to talk about the new define column statement, the capability of creating a column, a calculated column that exists only for the lifetime of a query. So it's the same as creating a calculated column, but it will not be persisted in the model, so it does not occupy space. It will be computed only during the query. Still, this column has its own lineage, can be used in filtering, in grouping, and for any other feature. The main limitation is that you can use it only inside a query. Let's get started. I have here our usual Contoso model, but if I want to use the new define column statement, I need a query. This is the first limitation you need to keep in mind. You can create calculated columns that exist for the lifetime of a query if you have a query. If you don't have a query, you cannot create a calculated column that exists in the query. That is why you cannot use this feature to define measures. That is very different from variables. You can create a variable both in a query or in a measure, but calculated columns can only be created inside a query. So, because we want a query, we need to start writing code using DAX Studio. I open DAX Studio. Let's get rid of some space, some items to have some space, and we start creating a new column. Now, the first column we create is a sales category. We want to categorize products based on the sales net price. If it is greater than 1,000, then it is high, otherwise it is low. A very simple calculated column. We start writing a define column, and then define column sales category. Sales category. Then an equal sign, and what follows is the same expression that you would have used in a calculated column. You can rely on the row context over the sales table, so you can just write if sales net price is greater or equal than 1,000, then it's high, otherwise it is low. If you were to write this code in a real calculated column, that would create the column containing high or low depending on the sales net price. Instead, this column exists only in the query, but it actually exists. So I can make it follow by some code and, for example, group by this column. I can do a group by that groups by sales category and compute amount, which is our usual sales amount. Let's format the code. So I define the column and I use it immediately after to do the grouping by. If I run this code, it doesn't work. There should be summarized columns. Okay. And you see that I'm grouping by sales category, and this is the sales amount of sales that are of product with a net price greater than 1,000, and this less than 1,000, greater than 1,000. Being part of the define part of a query, you can use it in multiple statements. I can write another evaluate statement later that summarizes, for example, by product brand and by category. I run these two queries, and now you see I have two results. One contains the same result that we were seeing earlier. The second one is grouping by brand, and it's grouping by category too. So I have created a new calculated column that exists only for the lifetime of a query. It has its own lineage. It can be used for filtering and for grouping as if it was a regular column. One important detail that you need to think about is that it is really like a calculated column. That means it is computed in the filter without any kind of filter context. And that is very different from columns that you can create using @columns. Because when you use @columns, you are always subject to the current filter context. This is not the case for calculated columns. Let's see the difference with another example. Let's say that instead of categorizing individual sales, I want now to categorize customers or products. I want to define whether a product is a popular product or not. If a product sold more than $100,000, it's popular, otherwise it is not. Looks like a good calculated column solves the problem. And we can do that. We can define a column in the product table that we call popular product that checks if sales amount is greater or equal 100,000, then it's popular, otherwise it's just not popular. Please note I'm using a measure sales amount here. That's why, therefore, I'm relying on context transition to compute the sales of the current product. And then can write evaluate, summarize columns by product, popular product, and I compute amount, which is sales amount. This is nearly the same code we have written earlier. It's just that now we are using product instead of sales. And if I run it, I have the sales of popular product and not popular product. Things are different as soon as I create a filter context, because right now my evaluate statement is running with no filter context, but I can add further filter. For example, I might be interested in restricting the sales to only a year. So I add the filter, and I say I'm only interested in 2007. They need to be treated as a date calendar year. Now, what is the outcome now? First, I can run the query and look at the result. But the interesting thing is this sales amount, the sales amount that I computed here, was it the sales amount considering 2007 or not? The answer is no. No. Because 2007, the filter on 2007 is part of the filter context, and this being a calculated column has been computed outside of the filter context. So this code is very different from an expression that, let's write another evaluate. I can do again, summarize. No, I need to apply a filter, calculate table. Summarize. Let's start from the beginning. Evaluate. I can express the same code using evaluate, add columns to product, and I create a new column, popular product. This is a column created inside add columns, and I use the same code. So this generates a table that contains a popular product. We can look at the result by, let's remove that. That contains all the products plus the new column popular product. Then I can summarize it. So I can summarize it by popular product. I run it, and I have not popular and not popular. And finally, I can add amount, which is sales amount. Let me format the code, run it again. I have my number. And finally, I apply a filter. Calculate table. And I write date calendar year equal calendar year 2007. Let me format the code again, and before going to the end, I also add the code that I cut a few seconds ago. So we have the result of both queries at the same time. The summarize column that groups by popular product, and the more complex calculate table that accomplishes the same task. If I now run this code, you see that I have values coming here, and I have other values here, but they are different. 7.8 million and 7.2 millions. Why that? Because this expression, if sales amount greater than 1,000, that is computed inside the filter context by the year, whereas this column, popular product, is computed outside of the filtering that happens here. The filter happens later. It does not happen at the same time. So there is a big difference between using a calculated column in a query or using add columns to add the column to the query. In one case, you are computing, if you are computing the calculated column, that calculated column is computed outside of any filter context. If you are using add columns, that calculation happens inside the filter context, and this is very different. I want to show you another example because it is sometimes tempting to use these calculated columns in order to simplify your code. But again, the results are very different if you do not pay attention at the evaluation context in which the calculated columns is computed. Let's get rid of everything, and let's say that I have a query like this. I'm not gonna write it now because it's not complex and we just waste time. I have a query like this one. I'm evaluating summarized columns. I group by color, I compute the sales amount, and then I compute large customer sales, which is using calculate sales amount again, but it's filtering only the customer whose sales amount is greater than 100,000. So these are sales only made by customers who bought a lot of stuff from us. If I run the query, I obtain my result. I have different colors, the sales amount, and the sales of customers that are large. Now, it is kind of tempting to say, well, this filter, this entire filter, can be expressed as a calculated column in the customer table. So I can just take this sales amount greater than 100,000 and add the definition on the customer table. The find column, customer is large, that checks whether sales amount is greater than 100,000. And then I can create a new column. Let's call it large customer sales 2, where I compute sales amount, and I make the code simpler now. I can write calc customer is large equals true. Let's format the code. No, this way is a bit better. So I have now my column here. I'm computing the version with calculate and filter over customer and the version that filters the column, which is much more readable and looks much better. But the question is, do they compute the same number or not? Well, the answer is no. If I run the query, you see that the result is different. And again, the reason is this sales amount is being computed in the filter context that contains the color. This sales amount is computed without the filter over the color. So there is a big difference between the two. They would be the same if I comment product color. If I run it, the grand total is the same because now there is no filter context. But as soon as I add a further filter, the behavior of these two is very different. So it's totally fine to use calculated columns to simplify your code, but you need to pay attention that by doing that, you are not changing the semantic of your query. Let's go to some conclusion now. As you have seen, the define column statement is kind of a powerful one. You can create calculated columns that exist only for the lifetime of a query, and this is very useful. With that said, there are limitations. The first one, you need a query. You cannot use this feature in a measure. So you can use it if you write queries. You can use it if you create reports, like reporting services reports based on an analysis services model, but you cannot use them in measure. Besides, pay attention that the evaluation context is always there. So calculated columns, also when they are created in a query, they are evaluated outside of any evaluation context. Whereas columns created with add columns, they are computed inside the filter context where they are being used. So this semantic difference is very important and might lead to some confusion. Enjoy DAX!